Hi everyone, this is part 5 Calculus 1 exam questions. I have 10 final exam questions in this part. In the first question, the graph of f of x is given here, and as you see, this graph passes through the points 5, 4, 0, 2, and minus 4, 0. It is requested to find integral of f prime plus 3x squared from the point 0 to 5. This integral is equal to, I want to write this integral as the addition of two integrals. The first one is from 0 to 5, f prime of x dx, and the second one is 3x squared. I write 3 in front of the integral. So I have integral of x squared dx. This is equal to, using the idea of antiderivative or using the fundamental theorem of calculus, we know that integral of f prime is equal to f. Or you ask this question, derivative of which function is f prime? Of course, this is f. Derivative of f is f prime. X is from 0 to 5. This is the first part of the integration. The second part, 3 times derivative of which function is x squared, or what is the integral of x squared? This is x cubed over 3. And again, x is from 0 to 5. Now it's time to plug the boundaries of integration. For 5 we have f of 5, minus for 0 we have f of 0. This is for the first part. For the second part I have 3 times the upper boundary, 5 cubed over 3 minus 0. As you see, you cancel these two parts. Finally you have f of 5. What is f of 5? Using the graph of f, we know this is 4. What is f of 0? This is 2, and this is 125. If you do this, if you make this calculation, you have 127. Let's look at the second question. Let positive continuous function f be defined from the closed interval 0, 1 to the real numbers. It is requested to find the integral of this complicated function from the point 0 to the point 1. I want to use the substitution rule. Let's say 1 minus x is equal to u. In this case, minus dx becomes du. Since we have a definite integral, we have to change the boundaries of integration. When x is 0, u becomes 1. When x is 1, u becomes 0. So let's rewrite this integral. Instead of from 0 to 1, we have from 1 to 0. Instead of f of x, we have f of 1 minus u. Instead of dx, we have minus du. Okay, let's look at the denominator. Again, for f of x, we have f of 1 minus u, plus for f of 1 minus x, we have f of u. Since we have minus du here, I can change the boundaries of integration by multiplying a minus. So we have integral from 0 to 1, f of 1 minus u du. So we don't have minus here anymore. Divided by f of 1 minus u plus f of u. Let's call this integral by a. Let's say this is a, okay? And I want to add them up. I want to add them to a's. Let's look at this expression, a plus a. Okay, so this is a, and this is also a, right? Let me write the first integral. Integral from 0 to 1. Instead of x, you can write the variable u here. Okay, doesn't matter. So we have f of u du divided by f of u plus f of 1 minus u. This is 1a. Let's look at another version of a, which is written in this step. Okay. This is also a. Integral from 0 to 1, f of 1 minus u du divided by f of 1 minus u plus f of u. So This is equal to integral from 0 to 1. You have f of u and f of 1 minus u here. F of u plus f of 1 minus u. Since denominator is the same, look at the denominator. This is the same. I directly write the denominator. Finally, you can cancel these two terms. Then you have 1 here, right? This is 1. So you have the integral of 1 dx from 0 to 1. The answer of this integral is equal to 1. We have a plus a, which is 2a. Since 2a is equal to 1, a is equal to 1 over 2. So the answer of the given integral is 1 over 2. In the third question, the values of f at the point 1 and 7 are given in this problem. It is requested to find integral of this function from 0 to 2. What about this expression? Do you know what is this? Before introducing this expression, I want to write some simple versions. We know what is dx, but what about d of x squared, for instance? If you have this expression, it means take derivative of inside, which is 2x times dx. Let me slightly change the function. Instead of x squared, let's have ln x. So in this case, you take derivative of inside, which is 1 over x, times dx. Instead of specific functions, let me write the general form, which is f of x, d of f of x. Derivative of inside using the same manner. This is f prime of x dx. Okay. What about d of f of 3x plus 1, which is given in the question? So I can write this integral using this idea from 0 to 2, f of 3x plus 1 times, instead of d of f of 3x plus 1, I first take derivative of 3x plus 1, which is 3, then derivative of f, by chain rule of course, this is f prime of 3x plus 1, and finally dx. Okay, this is all. Now we are ready to use substitution rule to solve this integral problem. Let's say u is equal to f of 3x plus 1. If you differentiate each side, you have du is equal to derivative of f is f prime 3x plus 1 times derivative of inside 3 and finally dx. When x equals to 0 for the lower boundary of integration, u is equal to f of 1, which is 2. This is given in the question here. And when x is equal to 2, u is equal to f of 7, which is 4. This is also given in the question. Now we are ready to use substitution rule. In this case, this integral is equal to integral from 2 to 4. Instead of f of 3x plus 1, we have u. Instead of this expression, we have du. So it's very easy to calculate this integral. This is u squared over 2, integral from 2 to 4. If you calculate this, you have 16 minus 4 divided by 2, and this is equal to 6. In this problem, it is requested to find limit of this function when x tends to 0. When x tends to 0, upper boundary of integration tends to 0. This is why we have integral from 0 to 0. And the answer of this integral is equal to 0. Actually, integral from a to a is always equal to 0. So we have 0 over 0 case here. This is why we can apply L'Hopital's rule to this limit expression. So this is equal to limit when x tends to 0. Derivative of denominator is 3x squared. This is very easy part. Derivative of numerator, in order to find derivative of numerator, we need to apply fundamental theorem of calculus or Leibniz rule. I prefer to apply Leibniz rule. So what is Leibniz rule? We take derivative of upper boundary of integration, which is derivative of square root of x. This is 1 over 2 square root of x times we plug the upper boundary of integration into t variable. So we have sine x to the power 5 over 2. Okay, this is done. So when x tends to 0, let me substitute this expression. Limit when x tends to 0. We have 1 over 6 times sine x to the power 5 over 2 divided by x to the power 5 over 2. When x tends to 0, this part tends to 1. The answer is 1 over 6. In question 5, it is requested to find value of f at the point 5. Here f is a continuous function that satisfies this equality. As you see, the function f is given in the integrand part. This is why we have to take derivative of each side with respect to x. So derivative of left hand side is equal to derivative of right hand side. Let me first write down derivative of right hand side. It is very easy. 2x plus 1. Done. What about derivative of this integral? I want to use Leibniz rule to find derivative of this integral. So what is the rule? We first take derivative of upper boundary of integration. This is derivative of 5x plus sine pi x is 5 plus derivative of sine pi x is pi times cosine pi x. This is done. This is the first part of the rule. The second part, we plug the upper boundary of integration into t variable. So we have f of 5x plus sine pi x. Okay. Let's look at the question again. We need to find the value of f at the point 5. So this is f, right? So how do we make this part 5, right? This must be equal to 5. In order to have 5 here, we have to plug the value of 1 into x. So if we take x equals 1, then we have f of 5. So let's say x equals 1. For x equals 1, we rewrite the equality 5 plus pi cosine pi times f of 5, as you see, 5 times 1 plus sine pi, which is 0. So you have 5 of 5, f of 5, sorry, and right hand side is equal to 2 plus 1 is 3. Cosine pi is equal to minus 1. So f of 5 is equal to 3 over 5 minus pi. This is done. In question 6, a piece of graph of f is given here. Also, integral of f from 0 to 5 is given as minus 25 over 3 and the area S1 is given as 32 over 3 in square. We need to find the area S2, which is represented here. We know that we can represent S1 area by an integral. Since this area, S1 area, is below the x-axis, integral from 0 to 4 f of x dx is equal to minus S1 area. Okay, so what do we know? We know that when a region is below the x-axis, we multiply the related integral by a minus to get the area. Okay, it is the rule. So let me continue. We also know that integral from 4 to 5 f of x dx gives S2 area. Okay, so let's add them up. Integral from 0 to 5 f of x dx is equal to integral from 0 to 4 f of x dx plus integral from 4 to 5 f of x dx. So this is equal to integral from 0 to 4 is minus S1 and and S1 is given in the question. So we know that this is minus 32 divided by 3 plus this region is S2. And integral from 0 to 5 is given in the question. This is minus 25 over 3. So this expression is equal to minus 25 over 3. By a simple calculation, you can easily write S2 area. S2 is equal to 32 minus 25 divided by 3. This is equal to 7 over 3. This is done. In this question, we need to find a relation between A and B. This equality is given. So let me start from left-hand side of the equality. I rewrite left-hand side, integral from 0 to 1, A over B to the power x, so dx. Using the properties of integral of this function, we can easily write A over B to the power x divided by ln A over B. Okay, x is from 0 to 1. This is the answer of this integral. It's not so easy. Let me plug the boundaries of integration. When we plug, we have A over B divided by ln for x equals 1. We have this expression for x equals 0. We have 1 in numerator and the same number ln A over B in denominator. If you substitute this, you have 1 over ln A over B, right? ln A over B. The parentheses of this, we have A over B minus 1. This is the first part. This is the left-hand side of the equality. Let me make this equal to right-hand side of the equality. This is why we have A minus B. I substitute this expression. This is equal to A minus B divided by B times ln A over B. Okay. This expression is equal to logarithm base A over B E, right? So we can write left-hand side as ln E divided by ln A over B. Okay, I continue from this equality. So this equality implies A minus B. If you cancel these terms, you have A minus B over B is equal to 1, since ln E is equal to 1. So using this equality, you have A over B is equal to 2. So the relation between A and B is A equals 2B. This is done. In question 8, the result of an integral is given. It's requested to find the result of another integral. Let's apply substitution rule to this integral. Let's say u is equal to 2 sine x. 2 sine x. In this case, du becomes derivative of right hand side 2 cosine x dx. So we can rewrite this integral as this is equal to, since we have a definite integral, we have to change the boundaries of integration. When x is equal to 0, for x equals 0, u is 0. When x is equal to pi over 2, we have u is equal to 2 sine pi over 2. Since sine pi over 2 is 1, we have 2 here, right? So u becomes 2. We can rewrite the boundaries of integration. U is from 0 to 2. Instead of f of 2 sine x, we have f of u. Instead of cosine x dx, we have du over 2. du over 2. So this is equal to 1 over 2 times integral from 0 to 2 f of u du. Let's compare these two integrals, this one and this one. As you see, they are the same integrals. This is why this is equal to 1 over 2 times the result of this integral is given as 8. And finally, we have 4. It's a nice question, right? In question 9, the result of this integral is given as k, and we need to find the result of this integral in terms of that k. I want to start from this integral and I use substitution rule. Let's say x minus 2 is equal to t, a variable. In this case, dx becomes dt. Since we have a definite integral, when x equals 0, lower boundary of integration, t is equal to minus 2. When x is equal to 4, t is equal to 2. I can rewrite this integral. Okay, let's say this is equal to a. A is equal to integral. I rewrite the boundaries of integration from minus 2 to 2. Instead of x, I have t plus 2. Instead of e to the power x minus 2 to the power 4, I have e to the power, instead of x minus 2, I have t to the power 4. Instead of dx, we have dt. I can separate this integral as integral from minus 2 to 2, the first part, t times this function, t e to the power t to the power 4 dt. This is the first part. And the second part, 2 times integral from minus 2 to 2, e to the power t to the power 4 dt. Let's say this integrand is equal to g of t. Let's say this is g of t. Let me rewrite g of t again. This is equal to t times e to the power t to the power 4, right? So I want to check, is it odd or even? In order to check, is it odd or even, I plug minus t into t. As you see, if you write minus t, you have minus t, since the power is 4, you have the same thing, e to the power t to the power 4. And as you see, g function is odd. And we have a rule, if you have an odd function from minus a to a, if this function is an odd function, the result of this integral becomes 0. It's a known rule of integration. In this case, this integral is equal to, for this one, we have 0 plus this integral, 2 times integral from minus 2 to 2 e to the power t to the power 4 dt. If we know the answer of this integral in terms of k, so we will find the result. In this step, I want to apply the same substitution. Which is written here, to the first integral, to this integral. Okay, let's apply this substitution. So if you apply this substitution, this integral becomes, let me rewrite, this integral becomes integral from minus 2 to 2. Instead of e to the power x minus 2 to the power 4, you have e to the power t. Instead of x minus 2, we have t to the power 4. Instead of dx, we have dt. And we know that the answer of this is equal to k. It is given in the question, right? So, since this integral is equal to k, the result of the requested integral is equal to 2k. So, it's done. In the final question, we have a trigonometric integral and we need to find an equivalent version of this trigonometric integral. Look at the power of sine function. The power of sine is odd. This is why we can write this integral from 0 to pi over 2. Since the power of sine is odd, we save one sine factor. So we write cosine to the power 4x. Instead of sine cube, I write sine square times sine. Instead of sine square x, I write 1 minus cosine square x. Instead of sine square x, I write 1 minus cosine square x. Since I saved one sign factor, I write this here. Now I can use substitution rule. Let's say u is equal to cosine x. In this case, du becomes minus sine x dx. Since we have a definite integral from 0 to pi over 2, we have to change the boundaries of integration. When x equals to 0, u is equal to cosine 0, which is 1. When x equals to pi over 2, u is equal to cosine pi over 2, which is 0. So I can rewrite this integral as integral from 1 to 0, instead of cosine to the power 4, I have u to the power 4. Instead of 1 minus cosine square, I have 1 minus u square, since cosine is u. Instead of sine x dx, I have minus du. You have a minus here, so you can change the boundaries of integration. I can rewrite this integral as integral from 0 to 1, u to the power 4, 1 minus u square du. So we have this expression in this choice. This is done.